All right, well, hello everyone. It's almost the end of the day, so thanks for being here. My name is Mete Atamel. I am a developer advocate at Google. I'm based in London. And actually, I spoke at Shift back in 2018 when it was in Split. I really liked it. And then I came back in 2019. Then I wanted to come again in 2020, but then we had the pandemic and all that. And then after that, life got busy. So it's been 5 years since I've been here. But I'm very glad to be here today, very grateful. And today I want to talk to you about multi-modal LLMs. So I'll do a little bit of introduction on what multi-modal LLMs are and what they can do for you. But more importantly, I want to talk about how you can avoid the pitfalls with them, because they're not perfect. There's a lot of problems with multimodal and also regular LLMs. So I want to go through them, what they are, and then also tell you about what we can do about them. Everything I talk about today is already on Speaker Deck. So these slides are on Speaker Deck, and the demos that I'm going to show, they're already on GitHub. And I'm going to share these links at the end of the presentation. So if you want to get access to any of this stuff, it's already out there. All right, so let's look at the agenda. So it's very simple. I'll do an introduction, then we'll talk about the pitfalls, then we'll talk about what we can do about the pitfalls, and then in the end, we'll do a quick summary, okay? So let's do the intro first. So we are talking about LLMs, but let's remember that LLMs are part of this bigger landscape, this AI landscape. So at the top, we have the field of artificial intelligence. Underneath, we have machine learning. Then we have deep learning as a type of machine learning. And then we have generative AI, the type of deep learning that generates stuff. Typically, when we talk about LLMs, we talk about text, but that's also changing. And we also have some image generators that can generate images. And then more recently, we started having things like sound generators, video generators. So that's the whole field. But what we're going to talk about today is the LLM part, and more specifically, multimodal LLMs. Now, when we look at the LLM landscape, there's also a lot of different models from different companies. Google has Gemini, then there's the GPT-4, there's the open source models. So there's a lot out there, and it keeps changing, so we need to pay attention to that. Now, the Google's model right now is Gemini, and that's what we've been converging on. That's our brand. And it has many different versions, but the latest one is 1.5. And then there's a version called 1.5 Flash. That's the fast version of that. But the Gemini is the underlying model that Google has as of today. Now, when we look at the Google AI landscape, as I mentioned, Gemini model is the heart of that. And then the way you use Gemini model, you typically start with Google AI Studio. It's an online tool where you can just go in and start interacting with the model. So that's the easiest way to get started. But then if you want to build an app using Gemini model, you probably need a platform. And that's what Vertex AI is for. So Vertex AI is the AI platform of Google Cloud. And it has Gemini model, but it also has a model garden with different models, open source or not. Then it has things like vector search, search and conversation, so on and so forth. So all the things that you need around the models, that's what Vertex AI tries to provide. But typically, you would start from here, and once you get things going, then you would switch to Vertex AI, and then you will kind of build your app on top of Vertex AI on Google Cloud. So what is great about Gemini? First of all, it's natively multimodal. So by multimodal, the model understands text, audio, video, so on and so forth. So it's not just text. It's the most sophisticated model, so it has sophisticated reasoning. And it also has a really large context window. And this is very important if you want to do big analysis of data, like videos and code bases and stuff like that. And if you want to compare, for example, the Gemini 1.0 Pro, that was the original model, it was only 32K. But now Gemini 1.5 Pro is 1 million. And I think we just recently increased it to 2 million. So with that, you can analyze 1 hour of video, 11 hours of audio, 30K lines of code. So you can pass in a lot of data all at once. And Gemini would understand and answer questions about that. So that's the unique thing about Gemini. Now, of course, at this point, you might be saying, OK, Gemini is cool, but it's on Google Cloud. I don't use Google Cloud. I don't want to use Google Cloud. OK, well, in that case, you can use Gemma, which is the open model derived from Gemini. So you can think of Gemma as the slimmed-down version of Gemini. It's open, so you can take the model weights and run it anywhere you want. It's smaller, it's text only, it's English only, so it's not as capable as Gemini, but it is still quite powerful. So if you want to go with open source and don't want to do anything like Gemini, you can still do that with Gemma. All right, so that was a really quick introduction to the landscape of AI and generative AI and multimodal. So before we talk about pitfalls, let me just run a quick demo here. So here I am in Google AI Studio, and I mentioned to you that these models are multimodal now. So what that means is that we can pass in pictures, videos, and audios to them and get answers from them. So for example, in here, we have this picture of some ingredients, and then I tell the model, I have these ingredients above, I don't know what to cook, can you give me some recipe ideas, right? So we just run this, and I'm running against Gemini 1.5 Flash, and now the model answers, and it tells me that these are your ingredients, and these are the things that you can do with that, right? So that was quite easy. And you can also pass in audio, you can pass in video, and it will understand that. And the cool thing is that if you look at the code, how to do this from your code, this is in Python. It doesn't have to be Python. It can be other languages as well. But you will see that it's literally, so you create your model, and then you specify which model you want to use, in this case 1.5 Flash, and then it's literally just one API call. So you just create your message and send, and that's it. So with one API call, you get access to all this multimodal goodness. So that's Gemini and multimodals in general, but they're not great. So let's talk about what's wrong with them, and then afterwards we'll talk about how we can fix them. So first of all, I told you that LLM, like you just make an API call, it's just a single API call, and it just works. It's true, but you also need to do a lot of pre- and post-processing with LLMs. You need to get your prompt together in the right format. You need to send that over to the model. And then once you get the result back, you need to parse it properly and more. So even though it's a single API call, there has to be a lot of things that has to happen before and afterwards. So it's not as easy as just making a single API call. Another problem with LLMs is that, and probably the biggest one, they hallucinate, they tell you wrong information, and they tell you in a confident kind of way. And that can be a problem if accuracy is important for your application. Another problem with LLMs is that they rely on outdated public data, right? Because LLMs, like for example, Gemini was trained like 3, 4, 5 months ago, and it was trained on public data. So anything since then, it doesn't know. And then anything private, it doesn't know. So if you have some private data, Gemini doesn't know anything about that, and that can be a problem. Another problem is the outputs of LLMs can be chaotic. Generative AI is great. These models, they generate a lot of different types of things, but these texts can be anything, really. Sometimes it's just free text, sometimes it's Markdown, sometimes it can be JSON, sometimes something else. And that's not good for an application, because in applications, we want things to be more orderly so that we can program against them. But LLMs will just give you anything, really. That's the default mode, but you can fix that. Another problem is that the LLM inputs can get expensive. I told you, you can pass in like hours and hours of video to Gemini, which is great. But at the same time, if you are passing that video all the time, it's going to get expensive. You don't want to do that. What else? LLM outputs are hard to measure. So let's say you are tuning your application, like you are changing your prompts, so you're doing prompt engineering, or you're fine-tuning, or you're doing something else, or you're using another model. How do you know that it's actually helping? Well, you wouldn't know unless you measure. But how do you measure? That becomes tricky, because these LLMs, they give you these generic outputs. So how do you take that and convert into a number that you can measure? So that's kind of difficult, isn't it? All right. I hope I didn't put you off from LLMs because these are some of the problems, but actually there are some solutions that you can do, and you should do as well, because people usually get carried away with LLMs. They see this huge potential on, you enter a prompt and you get this response. Great, let me build an app. You can do that, but it's not going to be stable or consistent. So you need to think about these problems, and you need to think about how you can solve them. So let's talk about what we can do about these problems. So in terms of solutions, I told you LLMs require pre- and post-processing, right? So for that, you probably need to use an LLM framework. There are a lot of frameworks out there. LangChain is the most popular one. LangChain, it started in Python, and now they have a JavaScript version. And there's also a LangChain for Java version as well. So I think it's a good one to start with. And the good thing about LangChain is that it has high-level APIs that gives you the building blocks that you need to do this pre- and post-processing. And I'm going to show an example later on what I mean here. But you don't have to do all that yourself. You can instead rely on a framework like LangChain. Of course, there are others. There's Semantic Kernel and AutoGen from Microsoft. They're both open source. And they try to do similar things to LangChain. I found them as they're useful as well, but they're not as advanced as LangChain. On the other hand, LangChain, it has a lot of things built, and it can get quite confusing as like what's happening under the covers, because there's a lot of abstractions on top of each other. So there's also a talk around that maybe LangChain is too high level. At some point, maybe you want to drop that. So it's something that you need to decide on your own. I have a couple of examples on my GitHub that you can check out later if you like on how to get the same app working with LangChain and also with Semantic Kernel. All right, the other problem I mentioned is LLMs hallucinate. So for that, you need to do grounding. You need to ground your LLM with your own data or with public data. And there's a few different ways of doing this. There's the easy way, and there's the hard way that I'm going to talk about later. Now, the easy way is that if you are in a cloud provider, they usually have easy ways of grounding to your data. For example, on Google Cloud, there's grounding with Google Search. So you can basically tell your LLM, use Google Search in your answers. This is for public data. But if you have your own private data, then you can use grounding with Vertex AI Search. So Vertex AI Search, it's basically a ready-to-go search appliance where you can just plug in your data, and then with that you can ground your LLM, and then with that your LLM will know about your private data. And I have examples of both, so if you want to check them out, it's on my GitHub. But let me just show you the Google search quickly. So let's go here, and now I switch from Google AI Studio to Vertex AI Studio. And here I can have this prompt, like, what was the weather like in London yesterday? And if I run this, LLM will tell me that I don't have access to real-time information, because it doesn't. It was trained like 3 months ago. But what you can do is that here, there's something called ground model responses. You can check this, and then you can customize it. And then here you can point to Google Search if you want, or if you have your own data, you can point to Vertex AI Search. But let's choose Google Search here, hit save, and then run the same prompt again, and there you go. It says yesterday in London, the average temperature was 51 Fahrenheit, so on and so forth. So you see, it was so easy. I just checkbox something, and that's it. And if you look at the code, all you need to do is, well, you can skip all of this, but basically you just create a tool here. This is the tool that you need to create, and it's a Google search tool. And then you pass the tool to the generate function, and with that, you have your answers grounded to Google search, which is nice. So that's the easy way. But at some point, you need to use what's called RAG. RAG stands for Retrieval-Augmented Generation, and it's a technique to basically take your own private data and then feed that into prompts as context. And you want to do this basically for more control. If you want more control on how that data is fed into your prompts, then you need to get into RAG at some point. And the way RAG works is that there's basically 2 steps. First, the ingestion step, and then the query step. So in the ingestion step, let's say you have some documents that you want to use as your data. Um, First, you need to split them into small chunks, because these docs, they might be too big for the LLM context window. Then from the chunks, you need to create embeddings, which is the number representation of the text. Then you save that to a vector database. So that's the ingestion phase. Then the user comes along, they ask a question, so there's a prompt. You run that through the LLM embedding model again. You get the number representation of that prompt again. Then you ask the vector database, can you find similar documents to what I asked? So vector database will give you that answer. And then what you will do is that you will basically take your prompt, take the similar documents that you found from your database, and then answer the user. So that's the flow of RAG. And as you see, there's a lot of different steps that you need to do with ingestion and answering and all of that. So that's why, again, using a framework like LangChain makes sense, because LangChain kind of helps for this a little bit. But RAG gets complicated, so you need to answer the questions like, how do you parse and chunk documents? What embedding models should you use? What vector databases should you use? How do you retrieve the docs? How do you feed them to the prompt? What about images? If you have images, can you embed those? And the answer is yes, there's image embeddings as well. So it does get complicated, but I think you need to get to RAG at some point if the out-of-the-box solution doesn't work. So now let me show you this LangChain example with PDF so that you get an idea on why LangChain kind of makes sense. So let's say you have this PDF file for some private data, and you want to kind of feed that into a RAG pipeline. LangChain helps this with its own libraries. So for example, it's probably hard to see, but I'll try to make this a little bit bigger. So here I'm setting what's called a chain. That's why LangChain is called, you set a chain of things. And here first I'm using a pilot PDF loader to load my PDF. Then I use this recursive character text splitter to split those PDFs into chunks. And then you specify your chunk size and chunk overlap, how much they overlap. Then I create my embedding model. In this case, I'm using Vertex AI embedding model. Then I use a vector store. There's many choices here, but here I'm using Firestore vector store, and I point to my documents that was chunked by LangChain in here. And then with this, I get a retriever. And then at this point, I'm ready to kind of feed this to my Vertex AI model. So I create a Vertex AI model, chat model, and then I give it a prompt saying that, you are an assistant, answer these questions. And then this context will come from my vector store. So I just say, this is the context, but it will come from my vector store. And then I create a template with the prompt and the user input. And then in the end, this is the LangChain, basically. LangChain has these chains that says, create me a document chain, and then pass that to a question answer chain. And then with that, I have my whole setup ready to go. And then when you need to use it, you just say RAG chain invoke, pass in the user input. And then all the things that I explained to you about the RAG pipeline and all the embeddings and all of that is done for you. So there's a lot of magic behind the scenes, but LangChain kind of helps for that. All right, so that's RAG. Next one. We said LLMs rely on outdated public data. So what can we do about that? Well, there's something called function calling. And the idea of function calling is that you want to augment LLMs with external APIs for more real-time data. Okay? So that's the idea. You basically augment your LLMs with external API calls. And the way this works is a little bit different. So let's say the user asks, what's the weather like in Zadar, right? But the LLM doesn't know. What we can do is that we can feed this prompt to LLM, but we can also feed a tool to LLM. And we can tell LLM, there's this function called getWeather that you can call if you need to, okay? And then it goes to Gemini, and then Gemini sees that this is weather, Zadar, so it says, oh, I can use this function. So it makes a request to you to call that function. So it says, can you please call me this getWeather function with Zadar as input? Then you make the call to the API, you get the result, sunny, then you pass that to the LLM, and then LLM responds back saying it's sunny in Zadar, right? So what happened here is that we basically combine our application, our external API, and the model, and they kind of work together to make LLM more real-time, okay? That's the idea about function calling. And I have an example, the weather application here that you can take a look. I'll just show you quickly how it looks. All of this on GitHub, by the way, so feel free to check it out. But the code is basically, I define a function called location to lat long. So given a location, give me the latitude and longitude by calling this API. So this is my first function. Then the second function is called lat long to weather. So given latitude and longitude, give me the weather for that location. And again, this is calling an API. So I have these two functions that I want to make it available to my LLM. And then all you need to do is you just need to create a tool. So you can create a tool, give descriptions, and explain when it can be used and what are the parameters. So you can do this if you like. This will help the LLM to pick the right tool. Or you can also do it like this. You just say from the function, just create a declaration. And this also gives enough information to the LLM to call that function. And that's it. From then on, like when you create your model, you pass this weather tool to your tools. And then with that, the LLM will try to use these tools. And if we actually run this, so here, for example, I will say, what's the temperature, wind, humidity like in London, Paris, and Tokyo right now? If we run this, now we should see the calls to the functions, well, the request to calls from LLM. So let's see if this works. So now things are being called, but let's see with the Wi-Fi. I'll wait 10 seconds, and if not, yeah, so here's the prompt. And now the LLM will figure out that, OK, I'm calling location to lat long, London, Paris, Tokyo. I got those, and now I'm calling lat long to weather for those locations. And then once it has all the information, then it tells us this is the weather in these locations, right? So that's function calling. And I need to speed up because we have 7 minutes left. LLM outputs can be chaotic, right? It can be any kind of text, free text, whatever, right? And that's not good because we want to be able to tell what the format is. Thankfully, recently, there's most of the models, they started having this response type and schema. So you can specify the response type, and you can specify a schema for that. And with that, you can constrain what the LLM can return. Yeah, so that's basically what I said. And actually, if we just look at this quickly. So let's say I want the model to answer, list me a few popular cookie recipes. Initially, it will just give me plain text. I don't like that as a software engineer. So I go and say, OK, list me popular cookie recipes, but do it in this format. So I'm doing a little bit of prompt engineering. With that, we get close. But as you see, it's JSON Markdown. So it's JSON, but in a Markdown. So it's not quite JSON yet. But then I can go ahead and say, OK, give me only JSON. So by adding this, then the same thing becomes that. So now we are getting proper JSON. But let's say I also want to enforce a schema. So for that, I can just define a schema and say, OK, this is what we should have with the recipe name and the calories and the items and so on and so forth. And then I pass that to my model. And then if I run this, you see that the response is not only JSON, but it also has all the fields that I want. So this really helps to constrain the LLM to the format that you want. So they're not as chaotic anymore. And LLM inputs can get expensive. So let's say you're passing all these videos to your LLM all the time. It can get quite expensive. But you can use something called context caching. The idea of the context caching is that instead of passing inputs all the time, in every single prompt, you create a cache with that big data, and then you reuse that cache in different calls to your LLM. And just to, again, show you quickly how this is done. So for example, in here, if I ask the LLM, what are these papers about? LLM doesn't know, because it doesn't know what we are talking about. But then I can say, OK, this is your instruction, and this is your contents. And the contents are just two PDF, two research papers, right? So I can take these, and then I can create a cache context out of these. So I can just point to my context and point to my system instruction. And then from here, when I want to use a model, I get that model from my cache context, okay? And then at this point, if I ask what are these papers about, the model will know about it. But more importantly, if I keep asking about the same PDFs or the same videos and this and that, it will always use the cache instead of sending them over all the time and paying for them all the time, okay? So make sure you use this if you need to send lots of data to LLM. And LLM outputs are hard to measure, right? So you get basically some text, and if you change things, you get some other text. How do you know if it's good or bad? Thankfully, there are some evaluation frameworks that you can use. Deep-Eval, it's one of them. It's an open source framework. And also, if you're on Vertex AI has rapid evaluation or auto site-to-site evaluation. So it allows you to compare models next to each other, two models side to side. So you need to pick something. I actually have an example of Deep-Eval. I will just show this as the last thing. So for example, Deep-Eval, it basically allows you to kind of do unit testing of your LLMs, but with a little bit of intelligence. So what you can do is that first you create your model. So in this case, Vertex AI. Then you choose a metrics to measure. For example, one of the metrics Deep-Eval has is answer relevancy metrics. So how relevant is the answer to the question? And then you have your inputs. Let's say your input is why is sky blue? You create a test case. You create your metric with the model, and then you basically assert. And then under the covers, Deep-Eval uses LLM to see how relevant the answer was. So you can run this, and then actually, let's try to run it. Oops, sorry. Yeah, so I have it here. So I can just say Deep-Eval test run, and then answer relevancy. And what you will see is that basically you'll get a response like this, and it will give you a score, 1.0. And then it will explain, like, the score is 1 because the response perfect address is the input, providing a clear and concise explanation, so on and so forth. So this is one metric that you can use. Another one you can use is summarization. So let's say you want the model to summarize this. Then you can create a summarization metric. And then you can also provide some questions that you use to see how that summarization is good or not. And then you pass it to Deep-Eval. And then it will run it, and it will give you a score on that. And there's hallucination, and there's more. Let's see if this ran. Yeah, you see it ran, and it gave us a score of 0.89. You can specify what it means to pass or not. But it's not perfect, but at least it gives you some score that you can rely on, so that if you change your prompt, you can always come back and say, OK, let's run this again and see if it increased or decreased or things like that. OK, so that's that. And then there's actually more, but I'm almost out of time. But there's fine-tuning. So when do you do RAG versus fine-tuning versus using the large context size, right? It's not so clear. LLMs change all the time. So the models themselves, they change all the time. So you probably need to pin to a version of the model and make sure that when the new model comes along, you change that in a careful kind of way. You don't want to just update without checking. Jailbreaking is a big problem. So people try to change prompts to do what they want. So you need to have safeguards for that. People provide personally identifiable information in their prompts, and sometimes responses might include them. So what do you do about them? If you want to tune LLMs, you probably want to give users some feedback, like thumbs up and thumbs down, so that they can improve your LLM, kind of fine-tune your LLM. So there's all sorts of things that you need to think about. But I'm out of time, so I can talk about them. But my point is that, and by the way, this is like the summary of what I talked about. But my point is that LLMs are very easy to get started, but then very hard to kind of get it right and make sure that it works the way you want, and make sure that when you change, things don't break. Just like in regular software engineering, I think. But maybe it's even more nuanced in LLMs because they're not deterministic. You know, they kind of respond differently every single time. All right, so hopefully this was useful to you. If you want the slides, here's it's on speaker deck, and if you want all these demos and much more, it's on my repo. I don't think I have time for questions, but I'm going to be out at the party as well, so feel free to come and ask questions. Thanks very much.